Hey everyone, welcome back to Beyond the Map. If you've been here before, you already know what we do. We explore the parts of this world that don't show up on maps, the things most people would rather not think about. And today's topic fits that perfectly. Imagine being fully awake, your body still works, your senses are intact, but your thoughts aren't yours anymore. In the insect world, this isn't rare. It isn't experimental. It's been refined over millions of years. There are parasites so precise, so specialized, that they don't need to kill their hosts. They take control instead. They force insects to climb, to drown themselves, to serve a purpose they'll never understand. Today we're looking at 7 real parasites that hijack the minds of insects. This is Beyond the Map. Ophiocordyceps unilateralis, the zombie ant controller. This parasite begins as a single microscopic spore. It infects carpenter ants, most commonly ants from the Camponotus genus. At first, nothing seems wrong. The ant keeps working, eating, moving with the colony. But days later, the parasite takes over. The ant suddenly abandons its colony, something ants almost never do. It ignores pheromone trails. It ignores danger. Instead, it climbs up plant stems, up leaves, to a very specific height, temperature and humidity. Then its jaws clamp down on a leaf, locking permanently in what's known as a death grip. That decision wasn't instinct. The fungus hijacked the ant's muscles and behavior. Once the ant dies, the parasite grows out of its head and releases spores onto ants below. The ant was never fighting, it was following instructions. Ampulex compressor, the emerald jewel wasp. The emerald jewel wasp hunts cockroaches, specifically species like the American cockroach, but it doesn't kill them. Instead, it performs one of the most precise stings in nature. The wasp injects venom directly into the cockroach's brain. Not enough to paralyze it, not enough to kill it, just enough to shut down its fear response. The cockroach can still walk, still move, still react, but it no longer wants to escape. The wasp grabs the cockroach by its antennae and leads it like a leash into a burrow. Inside, the wasp lays an egg. When the larva hatches, it slowly eats the cockroach alive, starting with non-vital organs. The cockroach never panics. Fear has been chemically removed. Horsehair worms, Nematomorpha horsehair worms, don't start inside insects. They start somewhere much worse. These parasites begin their lives in water, ponds, streams, puddles, releasing microscopic larvae into the environment. Insects like crickets, grasshoppers and beetles become infected in 2 ways, either by drinking contaminated water or by eating smaller insects that are already carrying the larvae. Once inside, the worm begins to grow, slowly, silently. For weeks, or sometimes months, the insect lives a completely normal life. It eats, it jumps, it avoids water like it always has. Meanwhile, the parasite is growing inside its body cavity, curling, stretching, sometimes growing longer than the insect itself. And then when the worm is fully mature, it flips a switch. The insect's behavior changes. It becomes restless, erratic, disoriented. Something inside its nervous system is being chemically manipulated. The insect develops an overwhelming urge to find water and something that should trigger fear, not attraction. It walks toward ponds, toward streams, toward reflections it doesn't understand. And when it reaches the edge, it doesn't stop. The insect jumps in and drowns. Only then does the horsehair worm burst out of the body, fully grown, writhing free into the water where it can finally reproduce. The host is dead. The parasite is exactly where it wanted to be. What makes this terrifying isn't just the outcome, it's the timing. The worm doesn't rush, it doesn't panic. It waits until the host has done everything it needs, and then convinces it to commit suicide. No struggle, no resistance, just one final fatal decision. That was never the insect's to make. For Massospora cicadina, the fungus that turns cicadas into walking infection machines. Some parasites don't control movement, they control desire. This fungus is called Massospora cicadina, and it infects cicadas during their mass emergence cycles. At first, infected cicadas look normal. They fly, they chirp, they behave like nothing is wrong. But as the fungus grows, something horrifying happens. The cicada's abdomen begins to rot away, literally replaced by a chalky white fungal mass packed with spores. The insect is missing part of its body, and it's still alive. Instead of retreating or dying, the infected cicada becomes hypersexual. Males behave like females. Females behave like mating beacons. They aggressively seek out other cicadas, spreading the fungus through direct contact. The parasite doesn't stop the host, it keeps it moving, because a living, flying insect that wants to mate is far more effective than a dead one. Quick pause here. If you're enjoying this list so far and finding this stuff as unsettling as we are, you can support the channel by liking the video or subscribing. Alright, let's keep going. 3. Myrmeconema neotropicum. This parasite doesn't hijack its host all the time, it waits. The parasite is called Dicrocoelium dendriticum, also known as the lancet liver fluke. Its life cycle is complex and brutally efficient. It begins inside grazing animals like sheep or cattle, living quietly inside their liver and bile ducts. From there, the eggs exit the animal through feces and end up on the ground. Snails consume the eggs. Inside the snail, the parasite multiplies, then exits in slime trails, which are eaten by ants, usually from the Formica genus. That's when the real control begins. Once inside the ant, most of the parasites stay dormant in the body, but one single parasite migrates to the ant's brain. Just one, and that parasite takes control. As night falls and temperatures drop, the infected ant climbs to the top of a blade of grass and clamps down with its jaws. It freezes there, exposed, visible, perfectly positioned to be eaten by a grazing animal at dawn. If the ant survives until morning, the parasite releases control. The ant returns to normal, unaware of what happened. Then the next night, it happens again. This continues night after night until the ant is finally eaten. And once the bird or grazing animal consumes the ant, the parasite's journey is complete. Inside the new host, the parasite migrates to the liver, matures, and begins reproducing, releasing eggs that will initiate the cycle all over again. The ant was never meant to survive. It was bait. A living lure is used, released, and reused until the parasite gets what it needs. This parasite doesn't rush. It waits for the perfect moment, because in nature, patience is just another form of control. Entomophothora muscae, the fly controller. This fungus infects common house flies, Musca domestica. Once infected, the fly's behavior changes completely. It climbs to a high surface, spreads its wings, and freezes. Its body releases chemicals that attract other flies. When healthy flies land nearby, they become infected too. The host becomes a living broadcast tower, spreading the parasite until death. No struggle, no awareness, just obedience. Sacculina carcini doesn't just control behavior. It erases identity. This parasite infects crabs, most commonly the green shore crab, and its attack doesn't start with violence. It starts quietly. A microscopic larva enters the crab's body and migrates through its tissues, spreading like roots through soil. Instead of killing the host, the parasite grows an internal network that wraps around the crab's nervous system and organs. Over time, it begins shutting things down. The crab's reproductive organs stop functioning. Its hormones are altered. Its instincts begin to change. Male crabs slowly lose male behaviors. They stop fighting, stop competing, stop mating. Instead, they begin behaving like females, carefully tending, protecting, and cleaning a brood pouch that doesn't belong to them. That pouch is the parasite. Sacculina eventually pushes part of its body outside the crab, forming a sac filled with eggs, and the crab treats it like its own offspring. It protects it, aerates it, defends it from predators. The crab isn't aware that anything is wrong, because the parasite isn't just controlling movement. It has rewritten the crab's biological purpose. Why does it do this? Because killing the host would be inefficient. A living crab provides mobility, protection, and constant care. The parasite uses the crab as a permanent incubator. When the parasite's larvae are ready, the crab releases them into the water, spreading the infection further. After that, the crab remains alive. It doesn't recover. It doesn't regain its identity. It exists only to serve the parasite for the rest of its life. This isn't mind control. This is a biological replacement. None of these parasites think. They don't plan. They don't reason. Evolution rewarded whatever worked. And what worked was mind control. If behavior can be overridden this easily in nature, it raises a disturbing question. How much of free will is real? And how much is chemistry? Welcome to Beyond the Map, where the most dangerous places on Earth aren't always visible. And if you enjoyed this episode, feel free to like the video and subscribe for more.